Hi, welcome to Unit 4.0. This is part 2.2. So in this part, what we're going to do is we're really going to do a lot of practice problems. This is where all the CFUs are that you're going to work on. So as you saw in part 2.1, there are two gas law equations, the combined gas law equation, and we looked at how we can utilize that to quantify changes in gases. And there's also the ideal gas law equation. We didn't really use that, but we mentioned that this is used when you are not looking to quantify a change in the gas, but you actually just want to find the pressure, volume, moles, or temperature at a given moment. What we're going to do for these CFUs, this is just really practicing utilizing these gas law equations. And the strategy is to identify variables like your pressure, volume, moles, or mass, because remember you can get mass from moles, and temperature, right? So identify all your variables. And if you notice that there are changes, like we saw in part 2.1, if they were saying, oh, the temperature is increasing or the pressure is decreasing, if there are changes, then you're going to use the combined gas law at the top. If there are no changes, you can use the ideal gas law. Okay, the structure of the, as we go through, what you're going to do is you're going to have the CFU presented to you, which you have in your packet, and you're going to pause the video and try it without the hint. Then a hint will be presented if you need a hint, and then after the hint is presented, you're going to pause and try it with the hint. If you don't need the hint, and you've already solved it, just wait for the end, because in the last part, you'll have your answer and you can check your work. All right, so CFU 8. Tommy takes a 12-liter propane tank filled with 2.2 kilograms of propane to a cookout. If 0.2 kilograms of propane is used at the, I don't know what that means to say, but is used, what is the pressure in the tank if the initial pressure was 102 atmosphere? Assume the change in temperature is negligible. So sorry about that typo there, but okay, so you have your information here. What you're going to do now is you're going to try it on your own. And then if you get stuck, a hint will show up in about 10 seconds. Okay, so if you needed a hint, just with any problem, you want to read and annotate. So that's what I've done here. And I've annotated and color coded things based on whether I noticed that there was a change. So things that were initial, I color coded in blue. And then the final values, I color coded in red. Um, so I'm going to use, since things are changing, I'm using the combined gas law, and make sure you're going to cross out any variables that are not consistent or not including the problem. The other little hint for this one here is that they don't actually tell you the final mass of the propane, but they tell you how much of it is used. So you're going to have to calculate the final mass of propane based on how much is used. Okay, so let's look at the answer for this. We're using the combined gas law, and the variables that we need here are our moles, since we're given mass. We know that the moles are changing, and we also need pressure because that's the other thing that's changing. Everything else, volume and temperature, we can go ahead and cross that out. So we get P1 over N1 equals P2 over N2. And what we need to do is we also need to calculate the moles because we're not given moles, we're given mass. Once we have that, we can go ahead and plug in our pressure and our moles. So calculating the moles, this is the work for the initial. I'm given 2.2 kilograms. I got to first convert that to grams, so that's 2,200 grams. And then I divide it by the molar mass of propane, which is 44.1 grams per mole. And that gives me 50 moles for N1. For N2, what I need to do is they're telling me that 0.2 kilograms of the 2.2 kilograms were used. So first I did was I subtracted 2.2 and 0.2 to give me 2 kilograms. That's how much was left over. That's how much was my final. And 2 kilograms is equal to 2,000 grams. And so that's how I got that. Again, divided by the molar mass to get the moles, and I got 45 moles. All right, now we have all of our values, so we just go ahead and plug that in. Cross multiply, solve, and get P2 is equal to 95 atmospheres. Okay, let's try it with CFU9. So again, a 12-liter frictionless piston initially filled with 2.2 kilograms of propane has a hole in it and leaks 0.2 kilograms of propane in 1 hour. What is the final volume of the piston? So pause the video now, and then if you need a hint, it'll appear in about 10 seconds. Okay, so here are the key pieces of information. We're given the volume and the mass, and those are the two things that are changing. So everything else you can cancel out. Remember, mass is corresponding to moles. And just like with the previous problem, they're not telling you the amount of moles, final amount of moles, but they're telling you how much leaked out. So you have to calculate the final amount of moles as well, or final mass as well. Pause the video now, and then we press play again. The answer will be revealed. Okay, so here's the work for it. So I only need pressure and volume. Sorry. Sorry about that. The pressure doesn't change, so I can cross the pressure and the temperature out, and I'm left with the volume and the moles. And again, I need to calculate my moles. I'm going to plug in my volume once I have my moles calculated. This is my work for it. So once I have all my values plugged in, I can cross multiply and solve. Okay, CFU 10, an 80 milliliter frictionless piston containing 9.0 moles of helium gas at 1.01 atmospheres compressed to 50 milliliters. What is the final pressure in the tank? Make a prediction about whether the pressure will increase or decrease. Based on your prediction, does this answer make sense? Okay, so that's quite a lot to do, but take a moment now, try it, and then when you come back, we'll have a hint if needed. Okay, so in this case, we're given the volume and we're given the pressure. Those are the two things that are changing. The moles does not change. So with that being said, you're going to use the combined gas law. See if you can then plug in your information and solve for the final pressure. Okay, so we're going to cross out any variables that we don't need. In this case, we're going to cross out moles and temperature because we don't need those. We just need pressure and volume. And then we can go ahead and plug those in. And we get P2 is equal to 1.6 atmosphere. All right, about the prediction, you can predict this conceptually. So conceptually, you could say the pressure will increase because they will hit they being the gas particles, hit the wall more frequently since the piston is being compressed and there's less space for the gas particles to move. So it's like if you were running around a room and the room suddenly got smaller, the chances of you hitting the wall are going to increase because you have less space. So that would be more of a conceptual way of doing it. You can also do it algebraically, and this is the way that I think is oftentimes very useful, is using the P1V1 equals P2V2 equation. Again, we're using that because those are the only variables that are changing. Everything else we can cross out of the combined gas law. And you know that if the volume is decreasing, getting smaller on one side, pressure must increase in order to sort of maintain that balance. So like if P1 and V1 stays the same, but this is a constant, it's not changing, then we need to make sure that if this is going down, that goes up to sort of counterbalance each other. All right, CFU 11. Bottles for compressed O2 carried by alpine climbers have an internal volume of 5.90 liters. Assumes that such a bottle has been filled with O2 to a pressure of 137.7 atmosphere at 25 degrees Celsius. How many moles of O2 are in the bottle? So pause the video now, and then in about 10 seconds, a hint will appear. Okay, so here's the key information that we have: volume, pressure, temperature, and we're looking for moles. There's nothing that's changing here. So since nothing is changing, we're not going to use the combined gas law. We're going to use the ideal gas law. Now that you have all your information, you can go ahead and plug that in. You need to go back to find out what R is. It's a constant. Go back in your previous note packet. previous pages in your note packet. Great, so here's the work. We have the pressure, we have the volume, we're looking for moles, the gas constant is there, and the temperature has to be in Kelvin, so that's kind of the trick to make sure you convert that to Kelvin. Go ahead and plug that into the PV equals nRT equation, and we get the moles there. Last one, in this case we have a balloon filled, a 40-liter balloon is filled with air at sea level, 1 atmosphere and 25 degrees Celsius, is tied to a rock and thrown into a cold body of water, and it sinks to a point where the temperature is 4 degrees Celsius and the pressure is 11 atmosphere. What will the new volume be? So pause the video now, and if you need a hint, it will appear in 10 seconds. Okay, so here is the information. Notice that there are several things that are changing. So volume, pressure, and temperature are all changing. So I've just underlined those. Blue is the initial and red, of course, is the final. We're going to use the combined gas law. So whatever part of the combined gas law we don't need, make sure you cross it out. Great, so in this case, the only thing we don't need is moles, so we can cross that out. And then we can go ahead and plug in everything else. I just needed to make sure that my temperature was in Kelvin and that all units were consistent. So notice how the pressure is in atmosphere. It has to be an atmosphere on this side. Volume is in liter. That means when I solve for volume, it's going to be in liter. All right, so the strategies, remember, folks, is to identify variables. If there are changes, use the combined gas law. If not, use the ideal gas law. And that's it. Have a quality day.